So this is your third lesson for Chapter 8, Solving Linear Equations. In this lesson, we are going to do some review of working on two-step equations, and then we're going to look at how to break down word problems. I have some cheat sheets in the class that you can take if you want that help remind you of the different key terms for adding, subtracting, multiplying, dividing, brackets, and then equals, which could be helpful for you. So if you need one of those, make sure you see me to get one. Oh, there we go. So for this review, for these three questions, keep in mind that if it isn't in decimal form, you can always put it into decimal form. And if you can't put it into decimal form, then look at a way to find of getting rid of all the denominators, unless you feel confident with working with fractions. So in our first example, it's already in decimal form, so we're going to isolate the variable. Our variable is r. Right now it's being multiplied by 2 and it's being added by 0.3. So I'm going to get rid of the 0.3 first by subtracting. So we get 2r equals 0.4. Opposite of times by 2 is divide by 2. Now some of the things that I haven't been seeing, because I haven't been seeing you guys checking your work very well, so we're going to check on these ones. Okay, so 2 times 0.2, 0.4 plus 0.3, and we are looking for both sides to be equivalent, which they are, so that means we've solved correctly and we've checked correctly. Slide that over a bit. Okay, second example. When I look at this example, I realize that 1/9 and 5/6, those do not make nice decimals when I divide them. They don't terminate. So I need to find a number that if I counted by 2, or if I counted by 9, if I counted by 6, so a multiple of those three numbers that I can multiply by. So the first multiple that I come across is 19. So I'm going to times by, 18, not 19. 19 is prime. So we're going to times everything by 18. So that means we get 18 times 1x, so that's 18x over 2. You might show less work than this is fine. Minus 18 times 1, which is 18 over 9, equals 18 times 5 over 6. That's 40, 90. Okay? And now we're going to divide those fractions. Okay, so now we're going to divide, so we get 18 divided by 2, which leaves us with 9x, minus 18 divided by 9, which leaves us with 2, and 90 divided by 6, which leaves us with 15. Yeah. Okay, and so now this should be nice and easy to solve because there are no fractions, no decimals. It's a nice, simple two-step equation. Add 2 to both sides, and we get 9x equals to 17. Divide both sides by 9, and x equals 1 and 8/9, or 17 over 9, but we've simplified it. We ran out of room to check, so I'll leave you off the hook on this one, I guess. C, again, 2/3 makes it difficult for us to divide, so we get 0.6 repeating. That's not a nice decimal. So we are going to times by a common multiple of 3 and 4. So let's use 12. You could always use a larger common multiple. I like to keep my numbers small. So we're multiplying everything by 12. So we're going to go 12 times 3y. So we get 36y. 12 times 2, that gives us 24 over 3. And 12 times 3, that gives us 36 over 4. Some of you might do this step and the next step all in one, and that's fine. So then we get 36y plus 24 divided by 3, which is 8, and equals 36 divided by 4, which is 9. Now we have no fractions, no decimals, nice and easy, simple two-step. So y equals 1 over 36. any of those were a struggle for you, I would expect you to come into tutorials. So now as we're looking through our word problems, we need to make sure that we are pulling out the important pieces. You might use highlighters or pencil crayons or different color pens, whatever. So for this first one, it says, Colin has long distance phone plan that charges 5 cents per minute. So 5 cents per minute, that looks like it's a rate that might be important for us. For long distance calls within Canada, there is also a monthly fee. When you see something like that says a fee, that means it's a one-time cost that's going to be added. So in 1 month, his charges were, so charges, that's another word for total, which is another word for equals. Okay, so how many minutes did he call? So when it says how many minutes, that means we don't know what that is. That means it's going to be our variable. So he has a rate of 5 cents per minute for some number of minutes that we don't know, plus the flat fee of $4.95. We'll leave the money signs out for now. And the total is $18.75. And we want to know how many minutes can he talk for. So that means we're going to be looking for M. So instead of leaving 5 cents as 5 cents, we're going to change 5 cents into a dollar amount. So we're going to go $0.05 times M plus $4.95. Okay, so now we're just going to solve for M. So we get 0.05M is equal to 13.8 or $15.80. Divide by 0.05 on both sides, and M is equal to 276. So just because we've got an answer doesn't mean we've actually answered anything. If we go back to the end of the question, it says, how many minutes can he call? Or did he call? Well, he called minutes of long distance. If it asks you with a sentence, you should answer it with a sentence. Looking at the next one, it says, now suppose if Colin changes to a cheaper plan. So this plan charges 4 cents a minute. So again, there is a rate plus a monthly fee. So think about that. What does that mean? For how many minutes could he call for the same total charge of $18.75? So I'm not going to do this one for you. I've set up the last one for you. I want you to solve how many minutes did he talk for, and as a little extra bonus, how many extra minutes did he get for this same price on this new plan? All right, last one. For this example, I would recommend drawing it out. So it says Billy is helping his family build a new fence along one side of the yard. So I'm going to draw a fence. Okay. The total length of the fence is 28 meters. So I'm adding to my drawing as I go. So 28 meters. Okay. They worked for 2 days and completed an equal length of fence each day. I think that that's important, but I don't really know how to add that yet. So they completed an equal length of fence each day. On the third day, they completed the remaining 4.8 meters of fence. What length of fence did they build on each of the first 2 days? So the first 2 days, it says they completed equal length. So that means this piece of fence they completed in the first 2 days, they completed 2 equal amounts. So let's call that F and F. I would use L's, but L's end up looking like 1s. So they completed 2 equal lengths, but we don't know what that is. We want to know what length of fence did they build each of those days. So, well, the equation we can come up with is that all of those pieces of fence have to equal to 28. So F plus 4.8 has to equal to 28. We'll leave the units off of it just for now. Otherwise, we're going to have F and M's, and it's going to be confusing. So right now we have two variables, but they are the same variable. They're like terms, so we could add them together. So we could get 2F plus the 4.8 has to equal to 28. Now you might be thinking of this a little differently and come up with a different equation, and I'm okay with that. If you could demonstrate your process, and we should end up at the same place. So we're just going to solve for F now. And so I get 2F equals 23.2 meters. We want to know what one of those, that means in the first 2 days. So this is the total for the day 1 and day 2, but we want to know just on one of those days, what did they do? So we're going to divide it in half, and I get 11.6 meters. So each of the first 2 days, they completed 11.6 meters of fence. So then on the third day, they just have that last little bit left. Okay, so this is the last lesson before your quiz. Your quiz will be in the next class that I see you. Please make sure that you are prepared. Okay, by next class I see you, I mean next class after we work on the practice questions for lesson 3.